Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. In this session, we will discuss about shift and rotate instructions. So here, shift instructions means by using these instructions, shifting of the data will be possible. The data size may be either byte size or word size. Shifting will be performed by only one bit. And rotate instructions means by using these instructions will perform the data to rotate. So rotating the data may be either towards left or towards right. Sometimes rotation can also be performed including carry and excluding carry. So here in this case, rotate instructions also, the rotating of the data size may be either byte size or word size. Here while rotating, the content will be moved only by one bit at a time. And we are going to discuss about this shift and rotate instructions along with examples. Now, so coming to the shift instructions, here we have different classifications under this shift instructions. Shifting means shifting the data towards right or towards left. So in order to perform the shifting operation, we have different shift instructions like shift arithmetic left, shift logical left, okay, so shift right. By using these instructions, shifting of the data may be possible. The data size may be either byte size or word size, and the shifting will be performed by only one bit at a time. And coming to the rotate instructions, by using these instructions, we can rotate the content. The content may be either byte size or word size. So in this case also, the data can be rotated by including carry or excluding carry. So under this, we have some instructions like rotate right, rotate left, rotate right with carry, rotate left with carry. So all these instructions comes under this rotate instructions. Here in this rotate instructions also, the rotation will be possible only by one bit at a time. So here, let us discuss about the shift instructions and rotate instructions in detail. So coming to here, the first shift instructions. So we have different shift instructions under this classification. So one of the shift instruction is here SHL, SAL. Okay. So here this SHL represents shift logical, or so here this A represents arithmetic. Shift logical or arithmetic. So this L is left. Okay. So shift logical or arithmetic left. Okay. So this instruction here, it is used to shift the data towards left. And next shift instruction is SHR. So SHR. So here S represents shift. So here shift, R represents right. So you can call this as shift logical right. And next shift instruction is SAR instruction. So here SAR stands for shift arithmetic, shift arithmetic right. Okay. So these are the important three shift instructions we are going to discuss under this shift instructions classification with examples. Now, coming to here, rotate instructions. So what are the instructions that comes under this rotate classification means? First one is ROR instruction. Okay. So ROR represents rotate, rotate, right. Okay. So while rotating the data, it can be considered by using carry, by considering carry, or without considering carry. So this ROR instruction represents here rotate right without carry. rotate right without carry. And next rotate instruction is ROL instruction. So ROL represents rotate left. Here also this rotating towards left is without carry only. So here we should not consider the carry bit for rotation. And next rotate instruction is Rcr instruction. So Rcr represents here rotate right with carry. Rotate right with carry. And next rotate instruction is Rcl instruction. So Rcl represents rotate left with carry. Rotate left with carry. Okay. So these two are the rotate instructions. The rotation operation will be performed without considering the carry bit. Whereas these two instructions are the rotate instructions which performs the rotate operation by considering the carry bit. Okay. Next. So we will discuss about all the shift and rotate instructions in detail with the help of examples. Next one is here shift instructions. So the first instruction that comes under shift instruction is SHL, SAL instruction. So as we know here, SHL, SAL instruction represents shift, logical or arithmetic left. Okay. So that means here the contents will be shifted towards left. Okay. So the content size may be either byte size or word size. So if it is byte size, it consists of 8 bits. If it is word size, it consists of 16 bits. And here the shifting operation will be performed towards left only bit by bit. Okay. So while the content is shifted towards left, you will have the rightmost bit vacant. Okay. So in this SHL and SAL instruction, that rightmost bit will be filled with the LSB bit. So here LSB represents least significant bit. Now, so here in this LSB, in the vacant bit, what we have to fill? By default, if it is SHL or SAL instruction, it will be filling the vacant bit with 0. Now, here, how many times the shifting operation should be performed means you can indicate in the instruction. Okay. So if it is only one time shifting, you can indicate within the instruction. If it is more than one time to perform the shifting operation, you have to indicate that with the help of a counter. That is by taking a value into a CX register and then indicating that into a count value. Okay. Now, so here the operand, it may be present in the register or a memory location. Okay. So, but it cannot be an immediate data. Now, so when this instruction is executed, all the flags will be affected. The condition of all the flags will be changed. So coming to the general format of this instruction, general format is SAL, SHL. So any one instruction here you may have. Okay, both the instructions perform the same function. Like vacant bit will be filled with the 0. Okay, so in this general format you can see destination and count. Okay, so here if it is only one time count, the count value can be simply represented as 1. If it is more than one time to perform the shifting operation, it can be represented with the help of CX register. That means you have to move one value into the CX register. Those many times the shift operation will be performed. Okay, and here destination represents the register. After making the shifting operation, again the result will be stored in the destination. Now, here, so coming to this, you can see here, it is an example given. Okay, so here in this example, we have considered a byte value. Okay. So this is B0, which represents LSB bit, and this is B7, which represents MSB bit, and this is the carry bit here. So in this case, here, in order to perform this shift left operation, okay, so here shift left means this B7 bit, whatever it is present, it will be going to here. And next, so this 0 bit will be going here. That means shift left operation will be performed by 1 bit. Next, so this B5 will be coming here. Here B5 is 1. It will be coming here. And next bit is B4. Here comes B4. And next, so this is 0. Next, 1. And here comes 1. And this B0 LSB bit, it will be going to here. Okay. So what about here in the output? In the output here, the LSB bit will be vacant. LSB bit will be vacant. This LSB bit will be filled with 0 when this SHL and SAL instruction is executed. So that is why here this is the vacant bit. It is filled with 0. So in this way, the SHL and SAL instructions will be operating. So the shift left operation will be performed only by 1 bit. And next one is here, let us consider a 16-bit data. Okay. So here this is the shift left operation. So if it is shift left operation, the carry bit will be present at the left side. And here comes the 0th bit, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Okay, because you are considering here a word size data. A word size data in a register, and we are going to perform this shift left operation. Okay, now consider, for example, the data what you are taking here, 16-bit data is AC A5. So consider this is the input what you are taking in a register. It is a 16-bit value. Okay. So if this is the input value, first what we have to do is we have to write this value in the form of binary. Okay. So consider here this is the operand what you are taking as an input, and if you are performing this SHL instruction, how this operand will be modified and stored in the destination. Okay. So here we know the value of A, B, C, D, E and F. They are hexadecimal numbers. So here A, it's 10, B 11, 12, D is 13, E is 14 and F is 15. Okay. Now here in order to know the value of A, binary value of A, it is the binary value of 10. So here you can write as 1, 0, 1, 0. Okay. And next, so the binary value of C is 1, 1, 0, 0. And the binary value of A again, it is 1, 0, 1, 0. And next number is here 5. So the binary value of 5 is, here we should not consider a binary data while writing in the carry bit. So you have to leave this carry bit empty. After this, you have to write the value. So A value is 1, 0, 1, 0 and the value of C is 1, 1, 0, 0. And next the value of A again is 1, 0, 1, 0 and the value of 5 is 0, 1, 0, 1. Okay. Now, so first you have to write the input value in the form of binary. So we have written that. And next when this instruction is performed. Okay. So here let us take the count value as 2 for example. So this 2 should be moved into CX register or CL register. Okay. So 2 times the shift operation will be performed and it will be stored in the destination. Okay. So let us consider here this is shift left. So while making the shift left, this is the MSB bit, and here this is the LSB bit. Okay, so while performing the shift left operation, here comes 1 and this 0 will be coming into this bit. So it is 0, and here this 1 will be coming here. This is 1, and here this 0 will be coming, 12th bit will be coming under the 13th bit. So here comes 0. So similarly, 1, 1, 0, 0, 1, 0, 1, 0, 0, 1, 0, 1. Okay. So when this operation is performed, here the last bit is vacant. Okay. So in this shift left operation, you have to fill this vacant bit with 0. So you have to fill the vacant bit, which is LSB bit, with a value 0. Now, since here the count value is 2, so this is the first count. Okay. Now, when the second count is performed, again, one time the shift left operation will be performed. So if it is shift left, this 0 will be coming here. Okay. Again, one more time, shift left, this is 1. Okay. So this 0 will be coming here, because this is shift left, the data will be shifted towards left by 1 bit. So 0, 1, and here comes 1, 1, 0, 0, 1, 0, 1, 0, 0, 1, 0, 1, 0. Okay. And here this is the vacant bit. Okay. So this is the LSB bit which will be vacant. This bit should be filled with 0. Now, so since here the count value is 2, 2 times the shift operation has been performed. Now, the value what we are getting after the second time, that value will be stored in the destination hexadecimal value. Now, here, if you see here, this is the carry bit. We should not consider. So, in this case, the CY will be 0. Okay. So, but what will be stored in the destination? So, as I have told you, the destination part may be either register or memory location. So, in this, what is the data it is going to store means here. So, 1, 0, 1, 1. So, 1, 0, 1, 1, the hexadecimal value of this 1, 0, 1, 1 is B. Okay. So, here B. Next, so 0, 0, 1, 0. So, the value is 2. And here 1, 0, 0, 1. So, the value is 9. And next 0, 1, 0, 0. The value is 4. Okay. So, the input what you have taken is AC, A5. After executing this shift left operation by 2 times, that means the count value is 2. It has been changed to B294, and the carry bit is 0 in this case. So, in this way you have to perform this shift left operation. Next, coming to the shift right instruction, SHR represents here, SHR represents shift logical right. Okay, so when this instruction is executed, the content, the bits will be moved towards right by 1 bit. The bits will be moved towards right by 1 bit. Okay, so the data size here also it may be either byte size or word size. Okay, so when the bits are shifted towards right, the leftmost bit will become vacant. The leftmost bit is called MSB bit. That MSB vacant bit will be filled with 0 in this case. Now, so here number of times the shift operation should be performed. It will be indicated with the help of a count value. So, if it is 1, directly you can indicate. If it is more than 1, we have to indicate with the help of a CX register. Now, so here the result will be stored in the destination. Okay. So, here the result may be stored in the destination means the destination path may be either register or a memory location. When this instruction is executed, all the flags will be affected. Here coming to the general format, here SHR is the mnemonic, next destination and count. So here based on the value what you are giving in the count, those many times the shift right operation will be performed and the result will be stored in this destination. So here the destination may be either register or memory location. Next, so to clearly understand the shift right instruction operation, okay, so shift right means the carry bit will be at the right side. So consider any byte value which is written in the form of binary. So when this shift right instruction is executed, the content will be moved towards right by 1 bit. See here, this is B0. B0 will be moved here, and next B1 it will be moved here. That means the bit under B1 will be going under B0 because this is shift right operation. The bits will be shifted towards right. Okay, so this 0 will be coming here, and here is 1. Okay, so this is 0, and here 1. This is 0, and here it is 1. So during this shift right operation, what happens? All the bits will be shifted towards right by 1 bit automatically. Here, this is the MSB bit which will become vacant. Okay, so when this instruction is executed, here the MSB bit will be filled with 0. Okay, so here the MSB bit is filled with 0, like same as the previous case. Now, so coming to the 16-bit example, okay, so when this SHR instruction is executed, so for example, consider the word, okay, so input, that is operand, as same AC A5, okay, and the count value CL what you are taking is 2. Now, so here since this is a shift right operation, okay, so the carry bit will be present at the right side. Next comes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Okay, so this is the carry bit, and this bit is called LSB bit and this bit is called MSB bit. Next, so considering this value, 16-bit value as an input, you have to represent that operand. It has an operand in the form of binary. Okay, so as we know here, the value of A in the form of binary is 1, 0, 1, 0. Okay, and the value of C in binary to represent, it is 1, 1, 0, 0. And next again A, so it is 1, 0, 1, 0. And next value is here 5. It is 0, 1, 0, 1. Okay, now, so when this shift right instruction is executed, so here since you have taken the count value is 2, consider here this is the count value 1 and here comes the count value 2. So during the first count, when the shift right instruction is executed, the content will be moved towards right by 1 bit. So if it is moved, so this here 1, if it is moved towards right, next here it is 0 and next this is 1 and here 0 and next, so this is 0 and 1, here 0, 1, so this is 0, 0, 1, 1, this is 0, 1, 0, 1. Okay, so here the MSB bit is vacant here. The vacant bit will be 0. So here the vacant bit is MSB bit. So this vacant bit will be filled with 0 in this case. Now, when second time shift right operation is executed, instruction is executed, again here shift right. So this 0 will be coming here and next here 1, this is 0, 0, 1, 0, 1, 0, 0, 1, 1, this is 0, 1, 0, 1 and here comes 0. And here this MSB bit is the vacant bit. It will be filled with the 0 during this instruction. Okay. Now, after performing the second shift towards right operation, now we have to convert this value into a hexadecimal value. So, here we have to convert all these binary values into a hexadecimal value. And this last bit represents the carry bit. So, in this case, CY bit is 0, whereas here the result, what you are going to store in a register or memory location that comes under destination part will be a 16-bit value. Okay, so what will be the value here? See, the value 0010 is 2, 1011, the hexadecimal value is B, next 0010, it is 2, and next 1001, the value is 9. So here 2B29 will be stored in the destination. That means when this ACA5 is taken as input, if 2 times the shift right operation is performed, it will be changed to 2B29 value. And here the carry flag will be 0. And now, so coming to the SAR instruction, next shift op instruction. So this SAR represents shift arithmetic right. Okay, so this instruction is used to perform the shift right operation, same as the previous one. Okay, but when the shift right operation is performed, the data what you are considering can be either byte or word. So during shift right operation, the data will be moved bit by bit only. Now, so when the data is shifted towards right, the leftmost bit, that is MSB bit, will be vacant. Now, with what we have to fill that vacant bit? Okay, so in this case, the vacant bit cannot be filled with 0 by default like previous cases. Okay, so it has to fill with some new operand. The vacant bit will be filled with some new operand. Now, we will see here. Okay, so the operand what you are considering may be register or a memory location. And here also, the number of times we have to perform the shift operation, it will be indicated with the help of a count value. When this instruction is executed, all the flags will be affected. Now, coming to the general format of this SAR instruction. So here, SAR destination, count. So here the destination can be either register or a memory location. Okay. So if you are performing only one time the shift operation, in place of count, you can have the value 1. Okay. So how many times, if it is more than 1, if you want to perform the shift right operation, it has to indicate with the help of this counter register, that is by using CL register. Now, so here we are considering a 8-bit data in order to clearly understand the operation of this SAR instruction. Okay. So here shift right. Okay. So anyway shift right, the data will be shifted towards right by 1 bit. Okay. So this is B0. This B0 bit, it is shifted towards right by 1 bit. So it comes here. And next this B1 bit will be here. Okay. And next B2 bit will be shifted towards right by 1 bit. This, all the things will be filled here. Okay. So this is the MSB bit. Okay. Now, here in this case, this MSB bit is going to be vacant. Okay. So this MSB vacant bit should be filled with the LSB bit. So in this case, this is the LSB bit and here comes MSB. So in the vacant MSB bit, you have to fill with the LSB bit. So here in this case, the LSB bit is 1. So you are filling the LSB bit with, MSB vacant bit with 1 only. Now, so coming to this SAR instruction, in order to perform the 16-bit operation, when this instruction is executed, so this is shift right. So shift right means carry bit will be at the right. Next comes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Okay. Now, here, so let us consider, for example, the input what we are taking is AC, A5 and the count value is 2, for example. Okay. Now, here since the count value is 2, you have to perform the shift arithmetic right operation by 2 times. So, here you consider the operand, that is what we are taking as input. Next, you have to perform the count 1. Next, count 2. Okay. So, here it is AC, A5. So, you have to write this in the place of operand in the form of binary. So, here AC, A5. The binary value of A is 1, 0, 1, 0. Next, the binary value of C is here 1, 1, 0, 0. Next, again A. So, it is 1, 0, 1, 0. And next value is 5. Okay. So, 0, 1, 0, 1. Okay. Now, here, when this shift right instruction is executed, shift arithmetic right instruction is executed, the data will be shifted towards right by 1 bit. Okay. So, if this is shifted towards right by 1 bit, so here the 0th bit will come under the carry bit. Okay. So, this 0 and next 1, 0, 0 and this is 1, 0, 1, 0, 0 and here it is 1, 1, 0, 1, 0 and this is 1. Okay. So, here this is the MSB bit and here this is LSB bit. Okay. So, here this MSB bit is vacant. This MSB bit should be filled with the LSB bit. So, in this case the LSB bit is 1. So, you have to fill this vacant bit with 1. Okay. Now, when this second time shift arithmetic right operation is performed again, the second time the shift operation will be done. So, here 0, 1, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 1. Okay. So, here again, this is a vacant bit. So, this vacant bit should be filled with the LSB bit. Now, here the LSB bit is 1. Sorry, in the previous case, the LSB bit is 0. So, here it comes 0. Okay. Now, this value will be filled in the register or memory location. And so, coming to the rotate instructions here. Okay. So, here in this rotate instruction, the first one is ROR instruction. So, ROR represents rotate right without carry. Okay. So, rotate right without carry. So, while doing the rotation operation, carry bit will not be considered. So, in this case also, when the contents are rotated towards right, the rotation will be performed only by 1 bit. Okay. So, how many times we have to perform the rotation operation? It has to be clearly specified with the help of CL register. So, when this instruction is executed, it will not be able to consider the carry bit. Okay. So, when this instruction is executed, the carry bit will be excluded, will not be considered. Now, so here when this rotate right operation is performed, after rotating all the bits towards right, the leftmost bit will become vacant. Now, here The leftmost bit means MSB bit. Now that vacant MSB bit should be filled with the LSB bit. So when this instruction is executed, the flags like parity flag, sign flag and zero flag will get affected. Now, so in this case also, the operand what we are specifying can be either register or memory location, but cannot be any immediate data. So coming to the general format of ROR instruction, here ROR, that is rotate right without carry, destination, comma, count. Okay. So here in place of destination, we can have either register or memory location. So here in place of count, we can indicate how many times the rotate operation should be performed with the help of CL register. Now, so coming to here the ROR instruction, okay. So here rotate right. So the carry bit will be at the right side. Okay. So rotate right means here this is the LSB bit and here MSB bit. Okay. So to make the rotation operation, same first shift operation should be performed. In order to fill the vacant bit, we have to rotate the value of, in order to replace in the vacant bit. Okay. So first, so in order to perform this ROR instruction, rotate right. So towards right, first the shift operation will perform towards right. So all the bits will be shifted towards right first. Okay. So here all the bits will be shifted towards right. So what happens means the MSB bit will become vacant. This MSB bit should be filled with what? When this ROR instruction is executed. Okay. So this MSB bit should be filled with the LSB bit. Filled with LSB bit. Okay. So in this case, the LSB bit is here 1. So 1 is specified here. So for example, in some other case, this LSB bit is 0 means here in this MSB bit we have to replace with 0. So here if you see, this is the bit you are taking to rotate, excluding carry. You are not taking the carry bit. Before the carry bit you are considering and taking. Now, so coming to this ROR instruction, in order to execute this ROR instruction, let us consider a 16-bit data as input. Okay. So for example, to perform this ROR instruction, consider AF5D. The input, okay, and consider here the count value as 2. Okay, so here first, so this is rotate right, so the carry bit will be at the right side. Next 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and here it is 15. Okay, so this 0 bit is called LSB bit and this 15 bit is called MSB bit. Now, so first we have to consider this AF5D as operand input. You have to specify in the form of binary. Okay, so now, so AF5D, its binary value. First, the value of A is 1, 0, 1, 0. Okay, and next the value of F is all ones, 1, 1, 1, 1. And next, the binary value of this 5 is 0, 1, 0, 1. And next, the binary value of D, 1, 1, 0, 1. Okay. Now, when here, the count value is 1. Okay. So, let us see here, rotate right. So, the data will be shifted towards right. Okay, so here this is 1, 0 and 1, 1, 1, 0, 1, 0, 1, 1, 1, 1, 0, 1, 0. This is 1. And this is the MSB bit which is vacant. Okay, so this vacant MSB bit should be filled with the LSB bit. So in the previous input, the LSB bit is 1 here. So here the vacant bit will be filled with the LSB bit. Rotate. Okay, so rotate operation. So this LSB bit will be rotated and it will be placed in the vacant bit. So here the carry bit has been excluded. Now, so when here the count value is 2, then again the rotate right operation will be performed. So that is 0, 1, 1, 1, 0, 1, 0 and this is 1, 1, 1, here 1, 0, 1, 0, 1 and this is 1. Okay. So here this MSB bit is vacant in this case also. So the MSB bit should be filled with the LSB bit. So in the previous case here, the LSB bit is 0. So this 0 bit will be rotated to here. And here it is 0. Here also excluding carry. Now, so here what will be stored in the carry flag? So here the carry bit is 0. Okay. So when this instruction is executed 2 times, how the data will be modified? That modified data will be stored in the place of destination. So this destination can be either register or memory location. Now, so considering this value into a hexadecimal value, okay, so here this is 0, 1, 1, 0. So the value is 6, 1, 0, 1, 1, it is B. Okay, so 1, 1, 0, 1, the value is D. 0, 1, 1, 1, the value is 7. So here 6, B, D, 7 will be stored in the destination after performing the rotate right operation excluding carry by 2 times. Okay. Now, same ROL represents rotate left without carry. Okay, so rotate left without carry. So here the content will be shifted towards left by 1 bit, rotated towards left by 1 bit. Okay, so here when the data is shifted towards left by 1 bit, the rightmost bit, okay, the rightmost bit means LSB bit. So that LSB bit will become vacant. That vacant LSB bit should be filled with the MSB bit in this case, excluding carry. Now, so here the MSB bit will be transferred to the LSB vacant bit. Okay, so when this instruction is executed, flags like parity flag, sign flag, zero flag, all these flags will be affected. Now, so while considering here, the operand may be present either in a register or a memory location. So this is the general format of ROL instruction. So ROL destination comma count. So this count represents the number of times to perform this rotate left operation, and here destination may be either register or a memory location where the operand will be stored. Now, so coming to this rotate left instruction, same as the previous one, but it will be shifted, rotated towards left. Okay, so since this is rotate left, the carry bit will be at the left side. Okay, so here this is B0 which represents LSB and B7 which represents MSB bit. So when this ROL instruction is executed, so this 0 will be coming here. So this is 1, 0, 1, 0, 1, 1, 1. Okay, so after this, here the LSB bit will become vacant. Now, here with what bit you have to fill this vacant bit? This vacant bit should be filled with the MSB bit. Okay, so here in this example, the MSB bit is 0. So that is why here it is filled with 0. So you have to fill with MSB bit. Okay, the vacant bit should be filled with MSB bit. Now, so considering this ROL instruction, let us consider a 16-bit data. Okay, so ROL instruction. So consider here the operand, it is A, F, 5, D, and the value of count as 2. Okay, so when this rotate left operation instruction is executed by 2 times, how the content will be changed. Okay, so consider here. So consider here operand. So this is rotate left. So the carry bit will be at the left side, and here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. These are the bits here, and here it represents the LSB bit, and here this represents MSB bit. Okay. Now, so you have to write the operand in the form of binary. So the value of A in form of binary, it is 1, 0, 1, 0. And next one is here F in form of binary 1, 1, 1, 1. And next 5, that is 0, 1, 0. Sorry, here first you have to exclude the carry. So without writing the value in the carry, you have to write. So here the value of A. So the value of A is here is 1, 0, 1, 0. Next F 1, 1, 1, 1. Next 5, 1, 0, 1. And the last value is here D. It is 1, 1, 0, 1. Okay. So since here the count value is 2, when the count value is 1, okay, so if this ROL instruction is executed, rotate towards left. Okay, so here the data will be shifted towards left. Okay, so consider here comes 1, that is under carry, and next bit will be 0. Next 1, 0, 1. This is 1, 1, 1, 0, 1, 0, 1, 1, 1, 0, and here 1. Okay, so here the LSB bit is vacant. Okay, so since this is rotate left without carry, the vacant bit, that is LSB bit, should be filled with the MSB bit. Okay, so in this case, the MSB bit in this case is 15th bit, that is 1. Okay, so you have to fill this vacant bit with 1. Now, when the counter, second counter is operated, again this is rotate left. So here 0 and 1, 0. So this is 1, 1, 1, 1, 0, 1, 0, 1, 1, 1, 0, 1. Okay, and here this is 1, and here it is a vacant bit. So this vacant bit should be filled with the MSB bit. So here in this case the MSB bit is 0. So here it will be filled with 0. Okay. Now, so here considering this example, we can say that the carry flag is 0 value, and here in place of destination, okay, so in place of destination it can be either register or memory location. So here in this place the value will be changed. See here, excluding this carry, so the value of 1, 0, 1, 0, it is B. Next 1, 1, 0, 1, the hexadecimal value is D. 0, 1, 1, 1, it is 7, and next 0, 1, 1, 0, the value is 6. Okay, so here in the destination you will have B, D, 7, 6. Next, so coming to the next instruction, it is Rcr instruction. So Rcr represents rotate right. rotate, write with carry. So same as the previous one, but we have excluded the carry bit during rotation. But here, while considering this instruction, we have to consider the carry bit, and that carry bit should be rotated into the vacant bit. Okay. So here also the rotation operation will be performed only by one bit. But while performing this rotate operation, you have to consider carry bit also for rotation. And so here generally the carry bit will be pushed into the MSB vacant bit. So when it is rotated towards right, the MSB bit will become vacant. That vacant bit will be filled with the carry bit in this case. So when this instruction is executed, parity flag, sign flag and zero flag will be affected. And so here in this case also, the operand may be residing in a register or a memory location, but cannot be an immediate data. And the general format of this Rcr instruction is destination, count. So how many times you have to perform the rotate write operation with carry? So those many times you have to indicate in the count value. And here the destination can be either register or memory location. Now, so consider this 8-bit data example. Okay. So here, since it is rotate write with carry, so the carry bit will be at the right side. Here, consider this is B0 to B7 binary data. When this is rotated towards right, so this B0 bit will be coming under the carry bit. And next here, 1, 0. So this is 1, 0, 0. This is 0 and 1. And here coming to here, this is the vacant bit. Okay. So we will call it as MSB bit. Okay. So MSB bit will be vacant. So this vacant bit should be filled with a carry bit. This vacant bit should be filled with a carry bit. So here in this considered example, the carry bit is 1. So here this vacant bit is filled with 1. So that is why it is called rotate write with carry. Next. So considering the same example for 16-bit data. So consider here the operand value, what we are taking. What we are taking here is the input. It may be stored in a register or a memory location. So in this Rcr instruction, consider the input AF 5D. Okay. And the count value as 1, for example. Okay. So when this instruction is executed, since it is rotate write with carry, at the right side you will have a carry bit. Okay. So here next 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Okay. So this 15th bit is the MSB bit and this 0 bit is called LSB bit. Okay. So in this case, since AF5D is the operand considered as an input, okay, you have to write this value in the form of binary. Okay. So first here, A binary value is 1, 0, 1, 0. And next value is F. The value of hexadecimal equivalent is 1, 1, 1, 1 binary value. And next is 5, 0, 1, 0, 1. And next one is here D, 1, 1, 0, 1. Okay. So for example, in this case, consider 0 as a carry flag. For example, consider 0 is a carry bit. Okay. So when it is rotated towards right, here 1, 0, this is 1, 1, 1, 0, 1, 0, 1, 1, this is 1, 1, 0, 1, 0 and here comes 1. Okay. So this MSB bit is vacant. This MSB bit should be filled with a carry bit. So in this case, the carry bit we have considered is 0. For example, in the previous case, let us consider 0 has been the carry bit. Now in this vacant bit, MSB bit, you have to fill with the carry bit. So in this case, the carry bit is 0. So here you have to fill with 0. Now, so after performing this rotate right with the carry operation by 1 bit, that is 1 time, then the result here, it will be stored in the destination. The result will be stored in destination. So in this case, CY bit will be 1, whereas here in the destination, it may be either register or memory location. Okay. So here the value will be hexadecimal equivalent of this binary value. So 0, 1, 0, 1, it is 5. Next 0, 1, 1, 1, 7. 1, 0, 1, 0, it is A. And this is E. So here 5, 7, A, E. Now, so this will be the destination operand. And next instruction is Rcl instruction. So Rcl represents rotate, left with carry. Okay. So same as the previous operation, but the contents will be rotated towards left by 1 bit. So when the contents are rotated towards left by 1 bit, the rightmost bit, which is called LSB bit, will become vacant. Okay. So that vacant LSB bit should be filled with the carry bit, whatever the carry may be. If it is 0, it has to fill with 0. If it is 1, it has to be filled with 1. Okay. And so when this instruction is executed, parity flag, sign flag and 0 flag will be affected. And here the operand, it may be resided in a register or any memory location except the immediate data. And this is the general format of Rcl instruction, same as the previous instruction. So Rcl destination, count. So this is the general example for 8-bit data. So this is rotate left with the carry. So that is why at the left side the carry bit will be there. Okay. So when it is rotating, all the bits will be rotated towards left by 1 bit. Towards left by 1 bit. So when it is rotated, the rightmost bit, which is called LSB bit, will be vacant. This LSB bit should be filled with a carry bit. So in the previous case, the carry bit is 0. So here the 0 will be filled. Now, so coming to the 16-bit example for the same Rcl instruction. Okay. So consider here the operand is, for example, 9DB5, 16-bit data. And here consider the count value as 1. Okay. So since this is rotate left with the carry bit will be present at the left. And here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So we have to first write the operand in the form of binary. After rotating towards left with the carry by 1 time, how the content will be modified. Okay. So first here the operand is 9. So you have to exclude that carry bit. And then you have to write this in the form of binary. So the value of 9 is 1, 0, 0, 1. And next D, 1, 1, 0, 1. And next value is here B, that is 1, 0, 1, 1. And next is here 5, that is 0, 1, 0, 1. Okay. When the rotate left operation is performed with carry by 1 time, see, rotate left means here. Okay. So for example, consider the carry bit in this case as 0. When the rotate left operation is performed, here it comes 1 and this is 0, 0, 1, 1, 1, 0 and this is 1, 1, 0, 1, 1, 0, 1, 0, 1. Okay. So here this is the vacant bit. That is LSB bit is a vacant bit. Okay. So since this is rotate left with carry, the vacant bit should be filled with a carry bit. So in this case, the carry bit is 0. So the vacant bit will be filled with 0. Now, so from this, we can say here the carry bit is 1, and here in place of operand, what that is stored in a register or a memory location. Okay. So here excluding this carry bit, consider this binary value into the hexadecimal value. Okay. So here 0011 means the value is 3, 1011 the value is B, and here it is 6, and 1010 the value is A. Okay. So 3D6A. Okay. So this 9DB5 will be modified as 3B6A when this Rcl instruction is executed by one time. Okay. So in today's session, we have discussed about the shift and rotate instructions. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.